Number 9 is a very easy one. I like this one. Has nothing at all to do with chemistry. Every 3 times you clean your room, your mother makes you an apple pie. If you clean your bedroom 15 times, how many apple pies does she have to make for you? All right, what's the kind of arbitrary number here? The one that could change possibly? That 15, I'll call it cleanings. 15 clean. So we said that for every time you clean it, or every 3 times you clean it, you get 1 apple pie. So I'll put 1 apple pie for every 3 cleans. Cleans cancels out. Please don't use your calculator on this one. You should get 5 apple pies. Even 5.0. You're thinking sig figs here. Easy one. I like that one. All right, number 10. A Trumbull High senior was applying to college and wondered how many applications she needed to send. Her counselor explained that with the excellent grade she received in chemistry, she would probably be accepted to 1 school out of every 3 to which she applied. She also realized that for every application she would need to write 3 essays, and each essay required 2 hours of writing. Of course, writing essays is no simple matter. For each hour of serious essay writing, she would need to expend 500 calories that she could derive from her mother's apple pies. Right? 1 pie is 1,000 calories. How many times would she have to clean her room in order to gain acceptance to 10 colleges? All right, so what is the kind of variable here? The 10 colleges that she wants to get accepted at. So I'll write 10 AC, 10 acceptances. Well, if we look up there, it says she will get accepted once for every 3 applications. So I could write 3 apps for every 1 X. So our acceptances will cancel out, and we'll have how many applications she needs to send out. And there was 2 essays for every 1 application. The application cancels out. And then for every essay, it took 2 hours of writing. 2 hours for every 1 essay. Since it's no simple matter, she will expend 500 calories for every 1 hour of essay writing. In her mom's pies, there are 1,000 calories per pie. And as we talked about earlier, she would need to clean her room 3 cleanings to get 1 pie. All right, a lot of units to keep track of. But again, if we keep track of our units, it makes this problem very, very easy. So now we can solve this one. She would have to clean her room 180 times. All right, it's not bad if you just look at the units. Again, all we're doing, if we think about units wise and thinking about what conversion factor would come next, makes it pretty easy. If we were trying to do a bunch of ratios and all that, that would make this problem very, very difficult. Number 11, almost done. A neutron has a volume of approximately 1.4 times 10 to the negative 44th cubic meters and a mass of 1.675 times 10 to the 24th grams. Calculate the density of the neutron in grams per meter cubed. Well, my units that were given here, I have 1.675 times 10 to the negative 24th grams per 1.4 times 10 to the negative 44th cubic meters. Again, this is going to give my density, right? All we did was mass over volume, basically. And we get 1.196 times 10 to the 20th grams per meter cubed. A huge, huge number. Sig figs wise, we can say here there was 2 sig figs, here there was 4. Since we used division, we used the one that fewer number of sig figs. We could round this off to 1.2 times 10 to the 20th grams per meter cubed. But if we were going to use calculations, like which we're going to do in the next step, we would use this number when we plug it into our calculator. You always use the non-rounded off number when doing calculations. When you're giving the answer, you can round that number off. All right, B, what is the mass of 1 cubic centimeter of neutrons in kilograms? Well, I know I'm going to have to start with that. 1 cubic centimeter of neutrons. My units here are in meters cubed. I have centimeters cubed, so I need to convert. 100 centimeters for every 1 meter. Since it's 3, I got to do this 3 times. This will give me cubic meters. Now I can multiply by my density that I solved for in the previous problem, 1.196 times 10 to the 20th grams per meter cubed. My meter cubes cancel out. Am I done yet? No. I need to get into kilograms, not just grams. But that's easy. 1 kilogram is 1,000 grams. Grams cancels out. So now I got kilograms, which is what I wanted. Now I can solve through. Again, remember, you have to do this 100 over here 3 times. Do it all out, I get to 2 sig figs, right? Because 1.0 has 2 sig figs. I get 1.2 times 10 to the 11th kilograms. Huge, huge number. And finally, our last one, number 12. Automobile batteries are filled with a solution of sulfuric acid that has a density of 1.285 grams per cubic centimeter. The solution used to fill the batteries is 38% by mass sulfuric acid. How many grams of sulfuric acid are present in 500 milliliters of battery acid solution? What's the kind of arbitrary point here? 500 milliliters. All right, I need to get to mass, right, because we're asking for how many grams. So what I'm going to do is get this. I can't use milliliters. I'm going to convert into centimeters cubed quick. It's an easy one. And now I can use the density. That should be 1.285. Let me get my eraser here. There we go. 1.285 grams per centimeter cubed. Right, my milliliters canceled out, my centimeters cubed canceled out. So within there are 600. I put a decimal point there. I guess I was going in the scientific notation. I don't need it. All right, 642.5 grams. So that is my mass of my sulfuric acid solution. All right, so now I need to know what mass of just sulfuric acid I have in there. And it said it was 38%. So real simple percentage here. I just have to find out what 38% of 642 grams times, that's 0.38 or 38 over 100. And that'll give me my answer. 244 grams of H2SO4. Again, terrible with my sig figs here. I only had 1 to start. So I could round this off to 200 grams of H2SO4. All right, so you're all done here. If there's any questions, you could always email me, jkayer@trumbullps.org. Hopefully I'll get back to you in a timely fashion.